Okay, types of UAS analysis. I'm assuming everybody can see this screen as well. Okay, so what about the different types of UAS analysis that are available? I'm not talking at this point about specific uses in, for example, public safety or utilities inspections, anything of that nature. I'm going to try to make this a little bit generic. And again, as I go through this, think about maybe what you're teaching, the kinds of lesson plans you have, and where they might fit in to these basic components. So let's talk about that. Types of UAS analysis. Well, first of all, I think, in a very preliminary form, we have what we call just simple reconnaissance. The definition, a preliminary exploration or exploratory survey to gain information. Well, that makes sense. And if we look at it, just take a look at this field. Here you see just sort of a selection, maybe some of you recognize some of these, maybe not, of simple unmanned aerial platforms from the parent Mamba that you see over here that, you know, might cost you $100, $140, you know, if you get the first person view goggles and so forth. But, you know, that's very popular. And again, very affordable, even, you know, maybe being able to your particular school or district might have 5 or 6 of these that might be able to be shared between different classes and so forth. They also come with a little camera, and you can prepare your own still shots and videos and so forth. So from that to, of course, the Phantom 3, Phantom 4s, and so forth, which have been quite popular over the years. Of course, now you're getting into prices that you know, may run in from $900 to $1,500 to maybe a couple $1,000, but certainly in many instances affordable. The Mavic 2 Pro, of course, the Inspire 1, Inspire 2, the Matrice 210 or 200 series and so forth. So a range from maybe a couple of $100 to, depending on the kind of sensors, of course, that also are purchased and carried with this, you may be getting up into tens of thousands of dollars. So again, there's a wide range in there, some of which obviously you will not have access or really any use for. But again, this is the range that we have, and that for simple reconnaissance of just you know, like a farmer flying his field, doing crop scouting. You know, where are areas, for example, where my crop appears to be under stress, where it got washed out by the rain that we had you know, last week, something like that. The main goal is to basically put the drone up with a simple camera, simple sensor, fly it just around to see what can be seen, how you're, and you know, if there are other types of mitigation kinds of activities that need to be done, fine. But simple reconnaissance is a very important part and a very useful part of UAS analysis, and certainly something that would be very easy to incorporate into curriculum. This maybe seem like an odd shot to you, but I had an opportunity last summer to perform a reconnaissance survey. I am past president of the Minnesota Association of Professional Soil Scientists, and we have a summer field day every year. And you know, like soil scientists, we like to go dig holes and jump in them and see what we can see. But I used my Mavic drone in a couple of areas. We knew what kind of soils we wanted to see. So I flew over an area that we had permission to dig our pits in, and just did a basic scouting and reconnaissance. Combine that with known soil data. Here is a drone view of the pits that we dug. And when we actually went out, and then there we are down in the pits. But it resulted from just a very simple reconnaissance survey of where we should do this. Again, there was another site. Another simple reconnaissance use was another area that we were going to study. This is part of a ski hill. All this area was dug out to make this ski hill in the southern part of the county. But when they did so, they found that they uncovered an area of some old paleosols and so forth. So again, reconnaissance and scouting basically allowed us to go in, see where to dig, and to clear these areas out. And again, that was for part of our survey. Another important aspect, I think, of unmanned aerial systems would be surveillance. Now, obviously understand that as I talk about these, there's a lot of overlap, certainly between these basic aspects of types of UAS activity, but as it says, keep a close watch over someone or some activity, some event. Certainly, I think we see that there has been a lot of utility of drone imaging and so forth in terms of surveillance of wildlife, whether it's looking for deer herds, or in this particular case in Africa, of course, keeping track of elephants, even to the point of flying them low enough as we surveil them to steer them away from areas where poachers might be. So again, surveilling an area. This is kind of an interesting application. It's not in this country, it's in Pakistan, where drones are being used to, again, with the COVID-19 in this worldwide pandemic that we have, trying to keep track, trying to get a handle, again, on where people may be congregating that they shouldn't be, using thermal imaging, certainly, to see, which is not necessarily a proven technique yet, but to see if we can monitor people's temperatures to indicate where people who, may be ill or impaired and so forth might be. And of course, as you see here with the speakers and so forth, to try and warn people or try to keep them moving. Just a variety of applications, but it is basic surveillance. As much as some people may feel that that is an intrusion, it is an important part of what we're able to do. And certainly, and again, I think it goes without saying, and you probably got that out of the pre-workshop materials and so forth that you were able to review. What is making all this possible is taking conventional sensors that have been carried in large aircraft platforms or even orbital satellite platforms, and being able to not only miniaturize the platform as being seen here, but also the sensors that are carried in it. It's just been phenomenal. And again, it's something that I've seen over my 40-year career in terms of changes in technology that has been one of the most fundamental game changers that I have seen in remote sensing. Well, certainly with that, sort of a spillover effect, inspections. To ascertain through observation the characteristics or functionality of an object or a piece of equipment. The idea that we're able to put up sensors that can get to places that have traditionally been sort of inaccessible or very difficult to get at. And some of you may be familiar with this in your own states. I know here in Minnesota, our Department of Transportation has a drone team and is looking to develop others for bridge inspections. And you can imagine, well, I have seen it again over the years, where it's been very difficult, obviously, to take a look at structural fatigue. I know here in Minnesota, of course, a number of years ago, we had Interstate 35 bridge collapse that might have been better detected had we had better detection and inspection. So certainly, being able to get under and in those areas where it's very difficult or dangerous to be for inspections, certainly that's very important. We also see it here again in the upper Midwest, not only inspection certainly of things like bridges, but also turbine farms, wind farms. And we see those in many, many areas across the country in the developments, now not just here in Minnesota certainly, but throughout the Great Plains and Western states and of course elsewhere. But once again, we're talking about something that's very difficult to inspect, very dangerous in some instances, and maybe not being able to give you the kind of results that you need. Certainly you can see that with this drone. It's sort of an illusion. It's not actually sitting on the propeller or the prop here. But take a look at some of the damage that you see here that is being able to be imaged in a great amount of detail. And you can even see some of that, of course, on the support pylon here. Again, drone imaging has become very important as a part of what generally we just term inspection. Certainly that's the case with things like power line pylons, the lines, the transformers. Here now, not only just perhaps regular visual imaging, thermal imaging. Where are heat losses maybe that we're seeing along the lines? Where do we see them along the transformers and so forth? These are important things. And again, being able to fly that very quickly with drones, they provide a great tool, certainly, for basic inspections. Public safety. The welfare and protection of the general public from dangers affecting safety, such as, as it says, crimes and disasters. We have seen this, certainly the use and utility with firefighting. I know that certainly the Forest Service has employed thermal imaging on aircraft that are flying, would fly over large areas of forests and so forth that were on fire. And again, it's very important to be able to utilize these. When you think about the amount of smoke, debris that obscures your view of where the hot spots are, where you really need to be able to go and put your resources in there. Certainly, in some instances, maybe not large forest fires, but small grass fires and so forth, being able to put the drones up. And as you can see here from this other, being able to direct fire crews to, where they need to be. So yeah, this can be, again, very important. I remember an instance when I worked my way through school as a firefighter when I was going to school in Oregon. We had a lot of grass fires out in the Willamette Valley, and fighting them could be very difficult at times and somewhat dangerous. And I remember an instance where I was sitting on the pulpit. The fellow drove right into a fire because he didn't know it was there. And yeah, I got rather toasty that day. Having, had we had better maybe information or a drone like this, that's an occurrence that might not have happened. So yeah, for public safety purposes. As we know, with certain aspects, again, of police work, certainly, whether it's search and rescue, which is very important as we know, tracking criminals and the like. Again, here is a thermal image. You can see an individual here from an actual occurrence where you had a murder suspect that was hiding on top of a utility bin. And if you're on the ground, you might not know that individual was there. But again, police deploying, of course, the drone with the thermal camera, were obviously able to find the individual and apprehend them. It's unfortunate that we are going to be having a number of what we call specialists that are knowledgeable in certain areas that are going to be doing some video, will be joining us and talking about their specific uses of UAS. Unfortunately, the public safety officer that we had hoped to have this afternoon will not be able to be here. We have had an incident here in St. Cloud that has yielded some civil unrest over the last few nights, and sort of all hands on deck with the St. Cloud Police Department. So Dan McClure will not be able to be here to talk about that this afternoon, unfortunately, but we will have some of the material to cover that time. He probably would have been able to talk about an incident that we had a couple of weeks ago where he is a sergeant in the St. Cloud Police Department. I think we have here some 10 to 15 police officers who are part of teams that work with a couple of drones that the police department has. Again, like I said, everything from search and rescue to criminal apprehension and so forth. And I know 2 weeks ago, Dan was able to deploy his drone with the thermal sensor. We had an individual who robbed 3 convenience stores here in the space of 4 or so hours in the early morning hours. He even came back and robbed the same place twice. I don't know if he thought he'd find more cash or whatever, but he fled, but they were able to deploy the drone and apprehend him, finding him under some brush near an abandoned shed. So yeah, something like this, just basic public safety. We're also finding being used more and more, and I think you probably all have seen this maybe sometimes along the side of the road, obviously accidents, and an important part once, individuals, injuries are addressed and debris is cleared and traffic can flow again, certainly before you can clear that debris, you really do need to have accident reconstruction. Again, a lot of it for insurance purposes, criminal investigations, potentially, who knows what. It can be a rather tedious process, accident reconstruction, if, again, whether it's county police or state police that are deploying their accident reconstruction teams. It's a dangerous situation. It's a dangerous situation whenever you put people in harm's way on, areas of heavy traffic or whatever. And again, being able to maybe deploy a drone that might be able to get all of the very important and pertinent information that you need, and more importantly, measurements that are needed, precision measurements, whether they're using GPS or total stations on the ground, as I said. That takes time, anywhere from 4 to 5, maybe 6 hours. Flying drones under certain conditions, you can get that down to maybe 20 to 30 minutes. So again, the utility of drones and public safety, like we see here, can be very important. Uh, Before I talk about the last component here, which is mapping, I think it's important, and I touched on that a little bit, I think, in this pre-workshop materials that I had put up. But if you're going now to move out of just simple kinds of reconnaissance, surveillance, what's there, what isn't, what are the conditions, and that type of thing, and actually get into using these sensors to create precise, planimetrically accurate maps, then there is an element of drone imaging, really any kind of imaging, from the air that needs to be addressed. And that is what's called photogrammetric control. Whoops, here we go. So for many kinds of UAS missions, any kinds of aerial missions, but let's just talk about UAS right now. There has to be some way of taking the imagery that you gather and that you are generating and actually be able to tie it back to the position, actual position on the Earth's surface. And to do this, we need to have or to utilize what are called control points. And as the name indicates, it's any point on the ground whose position is known in object space and whose images can be positively found on the image. You know, the corner of a bridge abutment, a road intersection, a lot line, something of that. They're used, as it says, to orient and relate imagery to the ground. These could be simple XY coordinates of some grid, or if you have access to elevational data, then we add what's called a Z value to that. And they can be used, again, to photogrammetrically. And when we talk about photogrammetry, it's the precision or the ability to use imagery to identify features and make precision measurements on the imagery and relate that within certain levels of accuracy to the actual ground. Many of you, I'm sure, have seen this traveling down the roads, maybe in parking lots. You might see, you know, some large white painted X or cross. This happens to be in a neighboring county. Paint kind of wore off, but someone's going to come out, as they did here, and actually paint this on. And what it's really pointing to in this particular case is a land survey corner in Sherburne County, although you get them from the United States Geological Surveys, whatever. People have gone out and actually found the location of these points. They're points of known location. And again, they can be used in the creation of precision photogrammetric models, you know, with, you know, from your drone imaging. We were doing a project several years ago when we were mapping some agricultural fields and trying to ascertain what could be done about certain problems in soil erosion, conservation, and so forth. And you can see here we had a staff member go out and actually locate some known site or monuments in the field, and these control points, you can see them here. So again, these are field surveys. You just have to go out. This is actually off of southern part of the county. This is Google Earth. And like I said, you can actually see some of these. There's this road intersection, and here's where that actual point is. And if you were to actually take a look at it, there is a nail there, an actual nail. And again, that site would then be occupied, and the very, very correct, planimetrically accurate XY coordinate value, of course, would be measured. We can use artificial targets as well for this. These are artificial panels. You know, I mean, you can buy these, or you can, again, make them from, you know, just old plastic trash bags and put them out, establish a point, measure it. And of course, all of this is done prior to any kinds of flights, whether it's by aircraft, drones, whatever, because these targets will appear. I'll show you some examples here in a moment, actually appear on the image. But the point is, no pun intended, you actually have a known coordinate value to go with it. Sure. How you're going to incorporate this into maybe a class when you start talking about photogrammetry. As I will say, it is a rabbit hole that you don't maybe necessarily want to go down because you never know where you're going to pop out. A little bit of humor, but yes, I think that some of these concepts can be incorporated into curriculum, even maybe in the middle school level, just indicating that there has to be some way of taking an image and actually being able to place it on the surface of the earth. Because as you think about it, so much of a lot of map work, especially with inspections, using drone imaging and so forth, deals with utilities, deals, again, like I said, with public safety. Again, note the sewer cover that you see here and so forth. I mean, this is where it should be. I mean, that's where it is. But what if you had a scene here, the manhole, you know, appearing to be in someone's front yard because you don't have these accurate ground control components. It is a big problem. This is, of course, where the fire hydrant is located. It's not located in the middle of the street. So ground control, when it comes to two-dimensional mapping and so forth, as we will see, is a fundamental component of mapping and how you would wish, to what depth you would want to go into, bringing this in as a part of your drone curriculum and so forth, of course, is up to you. But it's something that should be discussed. Because again, even if you, as you take a look at it, there are some instances where that fire hydrant actually is in the middle of the sidewalk. Just so you get the idea, the contractor who did this thought that he couldn't, you know, really place it effectively between the curb and the sidewalk where it should have been, so he took it upon himself to put it in the middle of the sidewalk, which the city made him move back. So, yeah. Again, to give you a little bit of an idea of what these effects are like, here's the city of St. Cloud. It's a simple Google Earth image. We had the opportunity a couple of years ago to be able, or I did at least, to take my UAS class out. We wanted to do some imaging, to have a flight, and this was the first class, I think, experimental class that we taught in UAS. We asked the county if we could go to one of the parks nearby. I don't know if you could see this or not, but we're very near the St. Cloud Regional Airport here. And again, and, as you probably also appreciate, you know, you can't fly unless you have special permissions within certain distances of certain kinds of objects or activities, like an airport. We wanted to go out and use one of the parks, but the county had an ordinance that said no drones can be flown in county parks, mainly because an individual had taken his drone and flown it into an eagle's nest, and they didn't look upon that very well. But they did relent and allowed us to go up to a park, a somewhat more remote park along the Mississippi River, called the Mississippi County River Park. And this is the area, and this is the park. This is a roughly an area that we flew for that, and we'll take a look at it. So again, Steve Sorensen is going to be able to talk about this in a lot more detail this afternoon when he goes into geospatial and drone applications, and like I said, in a little bit more depth. Suffice it to say, I think you can see here, these are the individual photos that were taken on the flight that our class was able to do over the park. This is the resulting Ortho Mosaic, where all of those images were stitched together. Then you can kind of see the roads and so forth, trails in here. The thing, though, is that Ortho Mosaic, at least the, well, I should say, we did not use ground control initially on the Ortho Mosaic as it was created. And if you think about it, here's that Ortho Mosaic. Without ground control input, it kind of floats up there in space. So as we take a look at it, it could be anywhere. I mean, everything within it, of course, is correct. It's just not tied down, and that's what we need to do. We need to nail it down. We need to use those ground control elements or components to be able to get a photogrammetrically accurate two-dimensional orthomosaic. We're fortunate at St. Cloud State that we have a land surveying program as well here. You can actually get a degree in land surveying and the mapping sciences. So we have access to surveying equipment, staff, and several of the students in the UAS class were also surveyors. So, but prior to us flying that Mississippi County Park, we went out and actually established some ground control in much the same way as I just showed you previously. And here we see one of those as they're waiting for that information to be gathered. We used a couple of different kinds of control points. You see along this blue line, I've done an enlargement. You can kind of see this little white X in this black area. That's about a 4 foot by 4 foot plastic panel that you actually put out. And again, depending on the resolution of the camera that you have, you can pick it up, you know, relatively easily. They cost about $16. We also made some of our own through lids, little barrel lids and so forth that we marked. You can see another one of those here. So if you can employ ground control, then you can start to make accurate measurements, linear measurements, you know, area measurements. You can get accurate locations pretty precisely in geographic or plane coordinates and so forth. Again, that is why if you're going to do some type of mapping project in one of your classes, especially if you maybe have access to the software and so forth, which you might have, perhaps in a technical college to your program, something like that, then yes, you can do that. But here is finally, and I'll get off of this, the rabbit popping up out of the hole. This is, again, the Ortho Mosaic on top of a Google Earth image, as we can see here. And if it looks a little blurry to you, that's because really what we have are two images here. And you can kind of see it here. Excuse me. The upper left here is the image that did not use the Ortho Mosaic that was created without ground control. And you can see that here. This image that is underneath it, and again, I kind of used the top image as a transparency, or made it transparent so you could actually see both. You can see the degree to which that image is offset to the south and the east. And we actually did the measurement. It's off, all points would be off about 17, about 18 feet from where they actually should be. All right, just like the fire hydrant in the middle of the street type of thing. So Again, the importance, if you want to be able to integrate or have access to photogrammetrically precision photogrammetric versus non-photogrammetric data, these types of things can very easily be discussed and shown. So yeah, two-dimensional and three-dimensional mapping is probably the, in many instances, perhaps maybe the ultimate goal of what users of UAS imagery have in mind, because they want to be able to incorporate it into geospatially accurate databases. That's why you need that photogrammetric control. So the image isn't just hovering out up in the air, it's actually tied down to the surface. So certainly the display of Earth objects in 2 dimensions, simply sets of XY coordinate pairs, creating an orthometric map of a uniform scale may be the desired goal. If you have access to elevation data, being able to make a 3-dimensional model or surface can be important as well. And that's the whole purpose of 2-dimensional, 3-dimensional mapping. So when you think about it, of course, oh, look at that. We see the drone flying across, and what it's going to be photographing and measuring, as you look at it, of course, are the tops of buildings, in this case, the roofs, tops of trees, the ground level. Each one, of course, has a specified XY coordinate. Fine. If, again, you have access to elevation, about how close that feature is to the lens of the camera that was taken, you can add that Z value. And again, the basic difference is being able to simply show something in an orthoplanometric map component as seen here, that campus area, as opposed to having access to elevation data or height data, in which you can actually now do a 3-dimensional rendering. Again, all of it within certain levels of accuracy, very important. As I mentioned, Steve Sorensen will be getting into this much more this afternoon. But if you're going to do 3-dimensional or 2-dimensional or 3-dimensional photogrammetrically accurate mapping, the whole pre-flight planning process is necessarily, obviously, very, very important. This is just a simple layout, the yellow lines that you see in there, and the sort of green bulb, light bulb sort of shapes are the layout for the flight plans and the corner turns along those lines of flight for a particular study area. All of this is done in the pre-flight planning process. Afterwards, of course, all of those images that you're going to get are going to have a certain positional component or model that can be done and presented. Like I said, some very detailed and perhaps expensive software. Some of it, of course, open source as well out there. Steve will be talking about that this afternoon, are available. Again, to create those Ortho Mosaics. And again, going back to our Mississippi County Park, an Ortho Mosaic, but as you will see, we can also create what are called digital surface models, where all of these points, again, are going to be a certain height above the ground. And again, you can get an idea of where the higher and lower areas are through that DSM model. You can take that DSM and create height classes, as has been done here, and drape it then over, there's that Mississippi Park area again. And sort of like, draping a sheet over a chair and how that sheet then conforms to the outline of the chair. Here too, of course, we've been able to model with our digital surface model that same kind of information and sort of warp it or overlay it, again, on top of another orthometrically accurate data set. So, having said that, however, I think it's also important to understand this, that, before you think, well, gee whiz, do I have to do 3 or 2-dimensional mapping to really be able to use this in my class if I'm going to do some kind of flights? Actually, of course, no. If that kind of detail is what you're after, then certainly. You have interfaces that will allow you to autonomously control your drone and its camera systems or scanning systems, whatever they might be, very accurately. And of course, as I indicated, employing the photogrammetric control is an important part of that. However, I think you all should be or should realize that there are indeed alternative types of flight plans that do not necessarily detail or have to detail that kind of accuracy with 2 or 3-dimensional map models. For example, and some of you may be familiar with this, just as drone enthusiasts and so forth. But some drones and, of course, the software that control their flights do have other components to them that allow you to do certain kinds of map flight plans or image flight plans without necessarily going into the kind of detail that we just talked about. There are some of the DJIs, again, like the Mavics and others do have the ability to do what we call intelligent flight. And you can go in, you don't necessarily have to use it, but if you so desired, you could. And take a look, and there are all sorts of different kinds of things that we can do. But again, as it might relate to reconnaissance and surveillance types of applications, or even certain kinds of inspections where maybe detailed map positioning may not be as important. We have things called quick shot and points of interest and waypoints and so forth that can be very useful. So if you were to go into, this is just we're using with the Mavic 2 Pro quick shots, you can do drones or rocket effect. These are kind of interesting effects, kind of the gee whiz types of things, but they also may have utility for bringing drone imaging into a simple classroom situation. For example, take a look at Circle. Now, this is, and I'll be talking more about this tomorrow, a project that our department has been working on with a number of partners. It's flying a specific kind of crop up in the central, or just west of here in the central part of the county. But what we did before we did any of the flight, the detailed kind of, 2-dimensional mapping flight components, was to put the drone up. And as you can kind of see, and I hope this works, yeah, you can kind of see the car. We simply centered it over an area and sort of spun it around in a circle, as you can see here. And again, the main idea of doing that, this is the field, by the way, that we're going to be looking at. It tends to put some things in perspective, and certainly being able to explain some of the components of a particular study, or to give people sort of a view of where they are, and a feel for the types of landscapes and so forth. Such simple kinds of flights can be very effective. and very informative, and especially for students or users who may not be as well versed in some of the more precision aspects, certainly of UAS and drone imaging. Okay. I think you'll find that waypoints can also be very effective tools because they too are things that are sort of pre-specified in a, if you will, flight planning, and maybe it's not the actual flight lines that you would do in a grid pattern or whatever, but they can be rather effective. And again, I would point out this area that you see here. You have a 1 and a 2 here, over here. These would be waypoints. So if you were sitting here at home and you put your drone up, it would fly to this first waypoint, and then to this one, and to this one, basically doing what you have told it to do. Again, you can fly it, something like this. And again, you can also have a determination of what direction the camera might be pointing as you do it. This is an area in which we are going to use waypoints. And again, this is all done, can be done pre-flight. You can do it in the field, and maybe you might find that to be more effective in terms of locating the study area and then your flight plan. Or, as in this case, you can select waypoints. And we're going to fly around this golf course area here. So we've put a waypoint here, as you can see, specified by 1. And then we're going to put another waypoint down here. And we're just, right now, under the waypoints, we can access either maps or satellite image as sort of backdrops that are, again, orthometrically accurate. And simply here, we're just tapping it with the stylus, putting in a second waypoint. We've specified it's going to be 50 meters above the ground in terms of the flight. And you can do that, of course, and just end it. And of course, wherever you end it, you can, you know, have it hover over the last waypoint. You can have it land, or you can have it, you know, return to the sort of the home base where you are. Another effective use, though, is to put another kind of point in here, and that's a point of interest. So that now, as you fly, you could have, and you can kind of see the little arrows in here as they're pointing. I'll kind of put that up here. So instead of just, you know, flying straight ahead from here to here to here to here and so forth, you can, if this was an area that you were interested in, actually specifying pre-flight planning here using intelligent modes, the direction in which you would like to have that camera point. You can have it pointing in different directions, as you see here, or you can select all of these waypoints and say, I want you always to be pointing at this center point of interest. So unlike the scene that I just showed you where we had the circle and we were just sort of pointing to see what the area around the field looks like, you could just do it the reverse and have that camera pointing inwards right to that central point. You could save that then, and when you go out into the field and get the drone ready to fly, instead of doing it in the field, you already have a pre-prepared flight plan ready to go. Again, not the precision kind of photogrammetric model, but simply the tasking that you do here. And again, that could probably be just as effective.